Hello guys, welcome back to a new video. And in today's video we are looking forward for the topic, one of the important topic of physics, at equilibrium. So without wasting time, let's begin it. First of all, I've just got some sort of beautiful pictures for you which will give you an idea what we will be discussing about, or what the equilibrium is. Like here we've got some sort of rocks, and they are placed in a manner, they are just placed at a sensitive position, but they are not falling because there is some sort of balance, some sort of conditions under which they are placed. So that is all due to the equilibrium. While we let's move forward. Like here we've got other pictures, uh, the same conditions. Like it is all something about balance. Like on a small point it is just balance, uh, on this it is just balance from both sides. So this is kind of a basic topic, uh, that uh, that is very interesting as well. Like here, you can see that it has got very useful uh, impacts on our daily life, techniques and daily like apparatus. So this is all about the equilibrium. This is the equilibrium which is acting upon it. uh, for the definition of equilibrium, let me state that equilibrium is the net force or the net torque acting on a body which uh, will be zero. Then the body is said to be in state of equilibrium. What does the definition means? This is a boring definition. Let me make you more clear about it. If this is a body and the body name is A, and if a body is applied by a force of 10 Newton from this side, where will it move? Of course downward. But wait a minute, this is not equilibrium. Equilibrium is something different. Here in this condition we have got no equilibrium. Now again, from the opposite side, if we have got a force of 10 Newton, so now you can say that the body would be balanced, because from the both sides there would be a same force acting. So body will be at a static state. uh, this is where the equilibrium is introduced. As the force is removed, or suppose that as a force from this side is maintained of uh, 10 Newton, so the body will move in that direction, the opposite direction. Body will move in this direction. So this means that the 10 and 10 Newton opposite forces just got balance, but while the one which is on the right side is unbalanced. So here the equilibrium is disturbed, while here if you got another force of 10 Newton, now it is all balanced. Now you know this is all the game of balancing the forces. So here it is said that now, for suppose here from the bigger rock we have got force 1, here we have got bigger rock force 1, and the force continues, and here till it you know this is all just stuck in between. Like from the both sides they will be having equal force. So this is the reason why it is in equilibrium. A body is at rest or moves with a constant velocity said to be equilibrium. Now this means that if a body is moving with a constant velocity, so it can also be in a state of equilibrium. Now for suppose, uh, for explaining you this thing, I would like to take example of a, uh, first of all, let's take water. Here is jar of water, and what will happen is this: let me fill some water in it. Here we've got water, pure water, beautiful. Okay, now uh, if you just drop an object in it, uh, now this will flow with a constant speed. uh, you know like just like it will flow with uh, 10 Newton force, maybe. Yeah, this would be, maybe the gravity wouldn't impact that much, but let us take example that this will fall with a speed of 10 Newton. Like if this falls in a constant speed, like from this point to this point it is 10 Newton. So this is termed to be as equilibrium state, because it has got a constant velocity from which it is traveling. So here how the equilibrium works. uh, Now I would like to move forward for the types or the states of equilibrium. uh, Static equilibrium, the ability to keep the body upright and stable without any movement. uh, what does that mean, like body upright and stable without any stable, just look at this word, stable and without any movement. Now these all over here, this one is a stable equilibrium, but the body is stable and there's no movement. Dynamic equilibrium, ability of body to keep body upright and stable in actions involving the movement or the subject of the movement. Okay, the balance depends upon a set of forces at each other side and which are regulated by the central nervous system. Okay, yes, dynamic. What does this mean? Like dynamic, it would involve movements. So I just given you example on this part. So let's look at this back. Now what is happening is like if this is moving in 10 newton downwards, so there would be opposite force acting as well, that will be making it in equilibrium, of course. So that is a for suppose 10 newton as well, that is the upright force which is acting on the body. So this is where equilibrium is stable, and now it will get back with a constant velocity downward. So this is the dynamic equilibrium. Movement is not involved. The center of gravity, even though this is not a particular type of it, but you can relate it as well. The center of gravity of the body is the point to which the forces of gravity exerts on the different material or consume the body product. Okay, yes, we have just discussed this complete point in our previous video, introducing the center of gravity. So you can check out that video for that. Conditions of equilibrium. Equilibrium, both reactions continue to occur. The system is dynamic. If the both systems are continuing to occur, like upward force, these upward forces, but this body is still moving. This is termed as dynamic. The system is closed, nothing did, nothing moved. Yes, of course, if you are having a body, let's suppose this one. Now if there would be air resistance, the body, this air is flowing in this direction, right? Air is flowing in this direction, the body will move in this direction. So this should not happen. This is not applicable. The system is closed. Okay, we are done with it. uh, the concentrations of the reactor and the products remain constant, of course. Yes, we cannot change the amount of force which you just place on this A object, or the size of the A object may also disturb that as well. Rate of the forward reaction equals rate of the backward reaction. Yes, this means that say from both sides we have got 10 newton force, it cannot taking place in 10 newton and 15 newton. uh, Equilibrium can be obtained from either from either side. Yes, of course, like it can be obtained from either of the sides. Like here we have got the states of equilibrium, and this is kind of simple. In this we'll just look at the center of mass or the center of gravity. So here is the center of gravity, and if a body is like force is applied in this direction, but the body comes back and it's got stable, so this is stable equilibrium, right? And for suppose now you will you will displace his body with the same force, and now it will fell down. So sorry, this is unstable equilibrium. Now if you just provide a force of in this direction, it will move in this direction and this, and there is no impact. Like this is the neutral equilibrium. This is how things work. I hope that you got the concept. If you did like the video, meet you guys in the next video. Till that, goodbye.